Okay, lesson 10 of unit 3, graphing polynomials from standard form given a factor. So our objective is to draw a rough sketch of a polynomial from standard form given a 0 or a factor. Understand multiplicity and determine the domain and range of polynomials. So, what have we done so far? We've factored using synthetic division when the remainder is 0, and we've graphed it to find the real solutions, only x-intercepts. So example 1, we have this polynomial, a cubic function. When we factor it out, we get x times x minus 3 times x minus 3, or x times x minus 3 squared. Over here to the right, we have that graphed. Notice we have two zeros, one at 0 and one at 3. We have a maximum, a relative or local maximum, and we have a relative or local minimum right there. Now notice in the example, the graph goes through 0 and bounces off of 3. So, yeah, imagine it's coming up as you draw it. It goes through this point here, 0, hits the maximum, comes down, it hits the 0, it hits 0 at 3, and bounces back up. If you think about it, we've talked about before when we introduced this idea, this counts as 3 and another 3. And why is that? Look right here. There are actually two 3's. Here's your 0. So remember, with a cubic function, you should have 3 zeros. And a lot of us will look at this and go, well, there's only 2 zeros. But we talked about this the very first time we introduced this, that when it goes through, it counts as 1, but when it bounces and hits off of there, it's twice. So there are 3 zeros right there. So let's talk about this idea a little further. It's called multiplicity. When a factor of x minus k, and when we were doing synthetic division, remember we were using that, x minus k, is raised to an odd power, then the graph of f crosses the x-axis at that point right there, x equals k. When a factor of x minus k is raised to an even power, the graph touches or bounces off the x-axis at that point, x equals k. So let's talk about this with some examples. From factored form, it's easy to determine the multiplicity of the factors. So, number 2, we have factored form, x squared times 3x minus 8. Well, what degree is it? Well, this is x to the first times x squared will give us a third degree, which makes it odd. Which means we're going to be looking at some kind of shape like that. The real zeros in the multiplicity, well, right here, 0. And if we set this equal to 0, we will get 8/3. And when we graph this, we would get, there's 0, here's 8/3, a little bit past 2. And it would bounce off the 0, come down, and go back up like so. Well, that's a rough sketch. Put it in the graphic calculator to get a better idea of it. But notice, the 0 has a multiplicity of 2 because it bounces off of that 0. And the 8/3 has a multiplicity of 1 because it goes through. So let's tie what we learned in this box up here to what we are experiencing down here. This is one factor, x squared. 2 is an even power. So what does that tell us up here? It's going to bounce off at that point, which is 0. And this is 3x to the 1. That's an odd power, like we set up here. And that means it's going to cross through that point. That's why it has a multiplicity of 1. Multiplicity just means, does it bounce or go through? So number 3. negative x right here, x minus 2, and x plus 3 squared. So let's think about it. The degree is going to be 1, 2, 3, 4, which is an even number. Now, the real zeros. Well, negative x, if we set that equal to 0, we're going to get 0. Since that's to the first power, we're going to get a multiplicity of 1. The x minus 2 set it equal to 0, we get 2. And that's a multiplicity of 1 also. Now the x plus 3, when we set it equal to 0, we're going to get negative 3. But you got to remember there's 2 of them. We have a multiplicity of 2. And remember, the graph of this is usually going to be our M shape or our upside down M shape. And since it's negative, it's going to be an M. So we're going to have 0, 2, and negative 3. We're going to come up and bounce at negative 3 and come down, go through 0, and down through 2. So here we have a bounce, and over here we have a through. On this one we had a bounce, and we had a through. Okay, now we're going to do some synthetic division. This should be a review for everybody. So we set this equal to 0. That's our number in the box. We have 2, negative 7, 4, and 4. Drop down to 2, multiply, add together, multiply, add together, multiply, remainder of 0. We started with cubic, so this is going to be 2x squared minus 3x minus 2. If we factor that, we're going to get 2x plus 1, x minus 2. Guess and check, whatever method you use. This is x equals negative 1/2, and x equals positive 2. We use the graphing calculator to get a picture of this and use it to get a table. We're going to get points like negative 1, negative 9, 0, 4, which is our y-intercept, 1, 3, 2, 0, 3, 7. Now notice, here's one of our x-intercepts, but we don't have the other one of negative 1/2. And that's because we're using only whole numbers. But if we plugged in negative 1/2, we would get 0. So the factored form is, we cannot forget what we started with, x minus 2 times our 2x plus 1 times x minus 2. And we graph that. Here's our negative 1/2. Here's our 2. Our maximum is going to be right there. We're going to come up, go through, hit. We have 1, 3 here to come down to. Going to bounce off of here. We have 3, 7 as a guide. Bounce off here, come up, and there's our general sketch of the graph. So once again, here we have a bounce, and our negative 1/2 is through. So our zeros in multiplicity, we have negative 1/2 as our 1, 0 with a multiplicity of 1. And we have the number 2 with a multiplicity of 2. This is our through. This is our bounce. Local maximum, use the calculator as you were shown. And you get 0.33, 4.63. So really close to our point right up here. We're a little bit past that, but we can't really see on here. Our local minimum was at 2, 0, where it bounced. Now, as we go left, it goes down towards negative infinity, and as we go right towards positive infinity, it goes up towards positive infinity. The domain, left to right, our classic negative to positive. The range, also going from negative to positive. And the y-intercept we found was 0, 4. Okay, number 5. X equals 1, which we actually got from x minus 1 equals 0. So that would what we would be dividing by x minus 1. We need to remember this for factored form. So 1 goes in the box. We have 1, negative 2, negative 3, 8, negative 4. And remember, these were already in descending order, but you got to make sure that's set up. Drop down, multiply, add. Multiply, add. Multiply, add. Multiply, add. There's our remainder. We start off with 4, so this is going to be 1x cubed minus x squared minus 4x plus 4. We factor this. We would do it by grouping. And we would end up with x minus 1 times x squared minus 4. But this here is the difference of 2 squares, which would come out to be x minus 1, x plus 2, x minus 2, equal to 0. So we have our 3 zeros right there. 1, 2, and negative 2. We're going to be kind of tight here. Our leading coefficient is 1. The degree was 4, which makes it even. The type, quartic. Factored form, cannot forget our original x minus 1. Then we got another x minus 1. Then we got our x plus 2, x minus 2. There's our complete factored form. Just a reminder, this could be written as x minus 1 squared, which is going to be our bounce. So our zeros, we We said we're 1, 2, and negative 2. We said 1 was going to be our bounce. So that's got a multiplicity of 2. Bounce. This has a multiplicity of 1. That's our through. And this has a multiplicity of 1. Another through. So when we sketch this, well, let's do our maximum minimum, make it a little bit easier to graph this. Our local maximum is at 1, 0. Once again, use the calculator for this. The minimums, of which are 2, negative 1.19, negative 12.4, and 1.69, negative 0.54. That's very tiny. Okay? So our local maximum is at 1, 0. Right there. That's our bounce. If we use our graphing calculator to get a better picture of this, we get some points like negative 2, 0, negative 1, negative 12, 0, negative 4. That's our y-intercept. 1, 0, 2, 0. And then we're off the chart at 320. So it's going to come down. Down to about, what was it? Negative 12 and a half. Somewhere around there. Come back up through negative 4. Bounce. Just dip down just a little bit. Notice negative 1/2. And come back up. So we have very tiny minimum and maximum right there, and another minimum right here. So what's our end behavior? Well, as we go left towards negative infinity, it's going up, positive infinity. As we go right towards positive, it's also going right up towards positive. So our domain, once again, left and right to infinity, negative and positive. Our range, approximately negative 12.4 to positive infinity. And our y-intercept was 0, negative 4. So there you go.